We're in Rosen, Discrete Mathematics and its Application, Section 1.6 on Rules of Inference. Here we're going to talk about how to build valid arguments using the rules of inference. And here we see that sort of the form of a valid argument is going to be a sequence of statements and a resulting conclusion. And some of these statements will be premises that we've been given. Others of the statements will follow from the premises using the rules of inference. And whatever reason we have for knowing these statements, we're going to write it down over here. So in this box over here, we'll write down the reason that each S sub I is true. And also for C. Okay, so let's take a look at our first derivation of a conclusion from premises using the rules of inference. Here we are given that the statement P and P implies Q is true as a compound proposition. And I want to show that Q is the conclusion. So in order to start this proof or this argument, we write down our premise. So the first step in almost any argument in this way is to write down at least one of your premises in the first position. So we've written it down, we've stated the reason that we know it's true is that it's a premise. All right, what can we do here? Well, something we can do with the conjunction of two propositions is to simplify. So that's what we're going to do is we're going to peel off the two arguments of this conjunction using simplification. So if the premise is true, then we can say that P is true using simplification. And I've written down my reason for writing down P is simplification, and then I've referenced the line that I've applied simplification to. We're actually going to do it one more time to get the other aspect of that premise. So we can also write down the statement that P implies Q, which is also a simplification based upon the first line, which was our premise. So I know all of these things are true, either because it's a premise or because we've used a valid rule of inference. And now what can we do? Well, now we have in 2 and in 3, we have the two premises for modus ponens. So using modus ponens, we can write down Q, and our reason is modus ponens using line 2 and line 3 together. And since Q is what we were trying to show, we are done. Let's look at another example. Here we have 4 hypotheses, and I'm just going to actually call them premises. And we can take them all to be true. It is not sunny this afternoon, and it is colder than yesterday. We will go swimming only if it's sunny. If we do not go swimming, then we will take a canoe trip. If we take a canoe trip, then we'll be home by sunset. Those are all given truths, premises. And we want to use rules of inference to construct an argument that concludes we will be home by sunset. So I'm going to reduce these to some atomic propositions. I'm going to let P be it is sunny this afternoon, R is we will go swimming, Q is it is colder than yesterday, S is we will take a canoe trip, and T, our conclusion, our hoped for conclusion, is we'll be home by sunset. And if I apply these and I go back into my hypotheses and I look for connective language, only if, then, I think there's some knots in here. We'll go back and look at those, then we can write down symbolically what each of those premises is. And if I do that, I get not P and Q. R implies P, not R implies S, and S implies T. And then conclusion, of course, is T. All right, so now we have 4 premises. We have their symbology, my conclusion. Let's go see if we can make that conclusion using our rules of inference. Let's construct our argument. Remember, the first line of any argument, almost always a premise. So we're going to write down not P or Q. Excuse me, not P and Q, pardon me. And with not P and Q, maybe we could do something with it. We could certainly use simplification. And that is what we do. We grab the not P and isolate it using simplification. Now we're going to grab another premise. R implies P. And now I have R implies P, but I also have not P from line 2. And those look like the premises for modus ponens. And with those 2 premises, I can conclude not R. So modus ponens on 2 and 3 gives me, modus tollens on 2 and 3 gives me the negation of R. Okay, let's look at the next premise is the negation of R implies S. Well, from line 4, I know that the negation of R is true. And if negation of R implies S, then I can conclude by modus ponens, in this case, by 4 and 5, that S is true. And I have one more premise that I can write down. S implies T. And since I have concluded that S is true using the rules of inference from above, I combine that with my premise that S implies T to conclude modus ponens that T is true. And that was what we wanted to show. And we've successfully done so using the rules of inference.